Okay, so my YouTube is live. All right. There's 1 minute left before class starts, so let me just wait until 4 o'clock. In the meantime, let me go to the files which I posted in the announcements. Okay, so now it's 4 o'clock. And what I've just downloaded are 2 past tests that cover the topics that you'll be tested on next week. And I figure this would be this could serve as a good review for preparing for that test. All right, so, okay. All right, so let me expand this so that it can be seen more clearly. And let me do the same for, hold on 1 minute. Same thing for this one. Okay, so which one shall I start off with? And this is where you guys have to chime in terms of answering questions and so on, because this is supposed to be to help you. Let me check something here. Is it this one? Or this one I should start off with? Okay, so I'm going to start off with this one here, all right? So let's start off with this question. Okay, I'm trying to figure out how to do this, because unfortunately I cannot write on this. So what I'm going to do is, okay, this is what you're going to do. You guys should go to Canvas and go to the announcements and download the questions, download the 2 past tests that I've posted, all right? So this is the section that you need to go to, the announcements, and the 2 most recent announcements are here and here. You click on those, and then you're going to see the attachment. Like, for example, in this case, you click on this, and then you see the attachment here, and you click on that to download the attachment, all right? And you do that for the other announcement I posted as well, all right? And the reason why I'm doing this is because I need to use my screen to actually show you the work. So let me bring this up on my other computer here. Okay, so okay, so what we're going to do, the first test is a past test, which is called test 2. The file name, I think, is test 2 spring 2015 or spring 15. Okay, so that's the test we're going to start off with, all right? So what I'm going to do is bring up my writing pad application here. And let me get rid of this here. Okay, so for test number 2, spring 15, there are some equations that you're asked to write down based on the information given, all right? So the first one, 1A1, says dicarbon dihydride plus oxygen to give carbon dioxide and water. So my question to you is, what are the formulas for the different substances involved in this reaction? I think I prefer to hear you say it rather than type it in the chat. So What's the formula for dicarbon dihydride? Let's start off with that one first. Okay, I guess it says it's locked. That is strange. Okay, let me see what's happening here. I'm not sure what is the cause of that, to be perfectly frank. Does anybody else have this issue? It won't let you down. Hold on. Like it says the file is in a folder untitled, which is locked. That is weird. How am I going to solve this problem now? Because I can open it easily from where I am. Oh, that is weird. It might be because the folder isn't published. Well, you see, the thing is, I attached this to the announcement. I didn't, hold on, let me see here. I attached it to announcement. It's not attached to, it's not in a folder. Let me see what this is here. Attachment. Oh shoot! I hate when this happens. I don't know what to do from this end. All right. How am I going to do this? I guess the best thing I can do is post it on the files. Okay, I'm going to post it under the files link and see if that would help. Okay, so I'm going to go to files and okay, I'm going to create a new folder. I'm going to call it today. And then I'm going to upload okay, it's taking its time. What? Unable to transmit file to storage service. The service may be down or you may need to relog it to campus. Okay, I don't know what's going on, folks. I'm so sorry about this. This is certainly something I didn't expect. For some reason, it's not allowing me to upload into the files section. Let me see here. Okay, let me try this again. Okay, so now it's uploaded. All right, so let's see if this would work. I want you guys to go to files. Oh, I guess I needed to log in. Okay, go to files, and then there should be a folder labeled today right here. Click on that, and then see if you can download that test. As you can see, I have no problem doing that. So I don't know if you guys, okay, let's see here. It worked, okay. At least it works for Caleb. Leslie, anybody else has any issues? Okay, good, all right, so 2 persons so far, so I'm assuming that it works for everybody else. Okay, very good. All right, so let's go back to what I was saying before. So the first equation is this one right here. I'm going to get out of this and get to my writing pad, but we're looking at question number 1A, the first one right here. So let me go to my, where is it right here? Okay, so can someone tell me what the formulas for the different substances are? Starting with the dicarbon dihydride. Okay. Okay, so C2H2, yeah, that would be correct for the dicarbon dihydride. So C2H2 plus, and the next substance is oxygen. What's the formula for the oxygen? O2, correct. And then on the other side, you have carbon dioxide, formula of which is what? Everybody should know what the formula for carbon dioxide is. Okay, yeah, CO2. And of course, everybody should know the formula for water, which is H2O. Very good. So once we identified the formulas for the products and the reactants, the next step is to balance it. So how do we go about balancing this equation? Well, put a 2 in front of the CO2, okay. Anything else? Put a 3 in front of the O2, you sure about that? Because if we do that, you're going to end up with 6 oxygens here, and you have 4 plus 1, 5 oxygens. So oh, you said never mind, okay. So I guess I need to erase that. Okay, so Taryn Stopinski basically jumped the gun and give the answer, but let me show you stepwise how you get the answer. So you'll notice that there are 2 oxygens here. Oops, let me use this here. You have 2 oxygens here, and you have a total of 4 plus 1, 5 oxygens on the right. So what I would do is put a coefficient of 5 over 2 in front of the oxygen. But of course, you know that you can't leave this like this because you want to have integers for coefficients. So what we do is multiply the entire equation by 2. So that will give us 2C2H2 plus 5O2 to give 4CO2 plus 2H2O. And that's basically how that is done. All right, so that's the first one. The second one, it says potassium oxide plus water gives you potassium hydroxide. So how would you solve that one? Let me get rid of this here. How would you solve that one? Potassium oxide plus water to give you potassium hydroxide. So what's the formula for potassium oxide? Okay, so according to Caleb Leslie, it's KO. I don't agree with that. So can somebody come up with the correct formula for potassium oxide? K2O, exactly. K2O, because remember, potassium, let me do this up here. Potassium has a +1 charge and the oxide ion has a -2 charge. So to get the charges canceled, you need 2 potassium ions for every 1 oxide ion. Okay, let me get my power cord so this doesn't go out on me. Excuse me for 1 minute. Okay, so let me plug this in. All right, now I'm in business. Oh, somebody's asking about doing the test at the testing center. The answer is no. I'll be posting the test online and you'll be able to do it at home or wherever you want to do it. Okay, going back to the question. So the next substance is water. And again, we know the formula for water, it's H2O. And then on the product side, the question says it's potassium hydroxide. So what's the formula for potassium hydroxide? KOH. Okay, very good. So that's the unbalanced equation. So how do we go about balancing this? Put a 2 in front of the KOH. And is that it? Yeah, I think so. Everything is balanced. You have 2 potassiums on either side. You have 2 oxygens on both sides, and you have 2 hydrogens on both sides. So that's basically the answer for the second one. All right. Now the third one, they gave you hydrogen peroxide that will react to form water and oxygen. So what's the formula for hydrogen peroxide? Okay, very good. H2O2, and it says it reacts to form H2O, which is water, plus oxygen, which exists as O2. So how do you balance this particular equation? Well, Come on, folks, this should be easy. Well, okay, so 2 in front of the H2O and a 2 in front of the H2O2. And yes, that is correct. All right. Okay, so far so good. The next one says aluminum plus oxygen to give aluminum oxide. So the formula for aluminum is Al. The formula for oxygen is O2. So what's the formula for aluminum oxide? Okay, somebody says Al2O, is that correct? Al2O3 is the answer for the formula for aluminum oxide. Okay, so how would we go about balancing this equation? Okay, so somebody says put a 4 on the aluminum, put a 3 before the O2, and put a 2 here in front of the Al2O3, and that is indeed correct. All right, so the last one, oh, wait a minute, no, there's 2 more in this series. Okay, so the 5th one in this series says sodium peroxide plus water to give sodium hydroxide and oxygen. So let me get rid of this here. Okay, so what's the formula for sodium peroxide? Anybody? Okay, very good. Na2O2, and it reacts with water, which is H2O. And what are the products of this reaction? Sodium hydroxide. What's the formula for sodium hydroxide? Okay, NaOH. And the other product is oxygen, O2. Okay, so how do we balance this particular equation now? Well, okay, so somebody's saying put a 2 in front of the H2O and also in front of the sodium hydroxide. Let's see what that gives. A 2 there and a 2 here. So that will give you 2 oxygens, I'm sorry, 2 sodiums, 4 oxygens, 4 oxygens, and 2. Okay, now based on that, the hydrogens will not be balanced because we have 4 hydrogens here, and this 2 here makes us 2 hydrogens. So I don't think that's correct. Okay, somebody's saying what? Put a 2 in front of the Na2O2. Let's see what that gives. So you're saying put a 2 here and a 2 in front of the water and a 4 here. Let me erase this here. So you're saying put a 4 here and keep the O2 the same. Okay, let's see if that works. You have 4 sodiums, 4 plus 2, 6 oxygens, 4 plus 2, 6 oxygens, 4 hydrogens, 4 hydrogens. Yes, so that would be correct. Okay, very good. The last one in this series, is silicon dioxide plus hydrogen fluoride to give you silicon tetrafluoride plus water. So what's the formula for silicon dioxide, firstly? What's the formula for silicon dioxide? SiO2, correct. Okay. And then what's the formula for hydrogen fluoride? HF. Okay, very good. And then on the product side, we have silicon tetrafluoride. So what's the formula for silicon tetrafluoride? Okay, SiF4. And then the last product is oxygen. I'm sorry, not oxygen, water, which of course is H2O. Okay, so now that we have this, how do we balance it? Okay, so somebody's saying put a 4 in front of the HF and put a 2 in front of the H2O. And I think that is correct because you have 1 silicon here, 1 silicon here, 2 oxygens, 2 oxygens, 4 hydrogens, 4 hydrogens, 4 fluorines, 4 fluorines. Okay, so that is correct. All right, so that's basically that part of question number 1. And then there's another part of question number 1 where they give you the unbalanced equation basically, and you're asked to balance it. So the first one is, let me get this out of the way. So the first one is NH3 plus O2 to give NO plus H2O. So how would you go about balancing this equation? Well, okay. Oh, I thought somebody typed something. Okay, any ideas about this one? Okay, so somebody's saying put a 2 in front of the NH3. And NO, okay, so put a 2 here. And 3 on the water. And a 5/2 on the oxygen. Yeah, that looks about right. 6 hydrogens, and then yeah. Okay, and then you're correct. You multiply the entire equation by 2, which results in 4 NH3 plus 5O2 to give 2 NO, I'm sorry, 4 NO plus 6 H2O. And that will be the answer. All right. Okay, I don't want to spend too much time on this part here. I want to get to some other sections. So I'm just going to do the next one, which is NaClO3 to form sodium chloride, NaCl plus O2. So how would you balance this one? Okay, so put a 2 in front of the sodium chlorate, a 2 in front of the sodium chloride, and a 3 in front of the oxygen, and that would be correct. Okay, so I'll leave you to try the others on your own. I want to get to the next question. In fact, I think what I have to do is bring up this question on the screen here because it's a table. And the question is asking for us to basically fill in the missing items, all right? So you'll notice that you have columns for different things. The first column is for the name. The second column is for the symbol. The third column is for the atomic number. Then we have the mass number. Then we have the number of protons, electrons, neutrons, and then the isotopic symbol, all right? So how shall we do this? Because I can't even write on this right here. Okay. Okay, so I'm just going to point to the spaces and you tell me what you would put there. I'm going to start with this row right here. So for A, what would be the name of this element? Okay, you're correct, potassium, but potassium is spelled with 1 T, not 2, all right? So please make a note of that, right? Potassium. And also it should be 2 S's, not 1. All right, so potassium, the name would go here. What's the atomic number that would go here? 19, very good. what would be the number of protons that would go here? 19 again. And what would be the number of electrons? 19. And what would be the number of neutrons? Okay, 20. See, somebody finally got it. 20, right? Oops. And then the symbol. What will the symbol look like? Well, what they're asking for is something looking like this. In the case of potassium, the potassium that we're looking at here, it will look something like this. 39 K 19. All right, so that would be, this is what we'd call the isotopic symbol for this particular isotope. All right. Okay, so and if you understand how to do this, you should be able to do the rest of them. So I don't think I need to go through this in the interest of time, but you know, on your own, you can try this on your own. And if you have any problems, then let me know. The B part is basically a similar thing. It's actually easier than what we saw in the A part because it says name the element which has the following numbers of particles. So my question to you is this: what would you look for in order for you to identify the element? The atomic number. And what's the definition of the atomic number? What is the atomic number by definition? The number of protons. Very good. All right. And also, you should recognize that in an atom, a neutral atom, the number of protons and electrons will be the same. So these are the things that you have to take into consideration in answering this question. So the first question gives you some number of different items. Where am I going to put this? Okay. So in the A part, it says 36 electrons, 49 protons, and 36 electrons, 49 neutrons, and 36 protons. So how would you find out the element of this particular, that is described by this? Okay, 36 would be the atomic number, yeah. So therefore, which element has the atomic number 36? Krypton, very good. All right. So of course, you'd have to consult the periodic table in order to get that information. All right. All right. The next one says 72 protons and 74 neutrons. So again, we go by the number of protons, right? So which element has 72 protons? Hafnium, very good. The next one says 5 electrons and it says neutral atom. So what does that tell you? Five electrons and it's a neutral atom. Has the same number of protons. Okay, so which element is that? Boron, very good. All right, and then the next one says 82 protons. So that gives you the number, the atomic number directly. So which element has 82 protons? Lead, okay, very good. And then the last one says 23 electrons, 27 neutrons, and 20 protons. So that corresponds to which element? Calcium, very good. All right, so that's relatively easy. Let's move on to the next question. Okay, so for the next one, they're basically asking you to write down the formulas for these names, for the following names of these compounds, all right? So I'm going to go back to my writing pad and let's start off with the perbromic acid. So what's the formula for perbromic acid? Well, very good. H, write it down here. HBrO4. Very good. All right. The next one is aluminum sulfate. What's the formula for aluminum sulfate? Well, okay, yep, that is correct. So let me write it down here. It's Al2, open parentheses, SO4, close parentheses, and then 3 outside as a subscript. All right. The next one is potassium sulfide. What's the formula for that? Correct. K2SO3 is the answer. Okay, very good. Oh, I'm sorry, this should be 3. Okay. And then the next one is calcium oxalate. What's the formula for that one? Calcium oxalate. Correct. CaC2O4. Very good. The next one is chromium 3 nitrate. Chromium 3 nitrate. So what's the formula for that one? Chromium 3 nitrate. Yep, that's correct. CrNO3 with a 3 outside parentheses. Okay. And then the last one in this series is zinc cyanide. Zinc, oh no, there's 2 more. But next one is zinc cyanide. So what's the formula for zinc cyanide? What's the formula for zinc cyanide? Correct. Zinc Cn2. All right. And then the last one is bromine. What's the formula for bromine? No. Exactly, Caleb, got it correct. It's Br2. Remember, bromine is one of 7 elements that exist as a diatomic molecule. You need to remember those. Hydrogen, nitrogen, oxygen, then you have fluorine, chlorine, bromine, and iodine, all right? So you need to keep those in mind. All right, the very last question on this particular test is asking for the opposite. They gave you the formulas, and they're asking for the names. So let me clear this here. Okay, so the first one that you're given is AlCl3. So what's the name of this particular compound? Aluminum chloride is correct. Okay, the next one is BaI2. What's the name of this one? Barium iodide, very good. The next one is, and think about this one carefully, SnNO2 4. What's the name of this compound? Tin 4 nitrite is correct. Okay, the next one is CuI2. What's the name of this one? It's not complete. Who is this? Giovanni Gonzalez. You're missing a very important piece of information in that name. Can somebody help him out? Thank you, Caleb. The answer is copper 2 iodide. You have to indicate the charge on the copper ion in this case, because remember, copper can exist as copper 1 and copper 2. So you have to indicate that in the name, which is what Caleb did. All right. Okay, what's the next one? H3P, and please note, this is in an aqueous solution. So what's the name of this compound? Well, hydrophosphoric acid is correct. Okay. And then the last one is SB2O5. Well, Okay. Tori, you're missing some important information there. So if that was given as a 2-point question, you get 1 out of 2 points. So what's the full name? Diantimony pentoxide would be the answer, yes. Yeah, so that's basically the answer to that one. All right. Let me try to upload the other assignment, the other test. Let me see here. So we can go over it as well. Let me go here. Let me go here. Let me go here. Go here. Download. Save. Oh, shoot. And then let me upload into the file called today. Okay, I just uploaded the other test. Let me in the same folder. Hold on. Let me reload this. Okay, yes, it's there. Test number 3, spring 15. So let me download that over here. Okay, so everybody got it? Okay, good. All right. So the first question, it gives you an equation. And it says if 30.0 grams of chlorine is reacting with 30.0 grams of HGO, what is the limiting reactant of this in this reaction? Well, the first thing we need to do is to ensure that the equation is balanced. And if you look at the equation carefully, you'll see that it's not balanced. So let's do that first. Whenever you're doing any stoichiometry type problem, the first thing you need to make sure is that the equation is balanced, all right? So this is what you're given. You're given HGO plus Cl2 to give mercury 2 chloride. Okay, somebody has a question. Will the test cover this material? Oh, good question. Thank you for pointing that out. Assignment 17. Let me check something here. Thank you for asking that question. Who asked that question? Stepinski. Let me see here. 17 would go up to okay, so let me see here. Okay, so I'm glad that Ms. Stepinski asked that question because this particular question will be outside of the range of questions that you'll be tested on because, hold on, let me see here, because the test will go from chapter 5 through 8 and the assignment for chapter 8, the last assignment for chapter 8 is assignment 17. So let us skip that question. Let's see what other questions can we do. Well, wouldn't be able to do number 2. Let me see here. Oh, wait a minute. So basically, okay, none of these questions. Oh, okay, number 4. Okay, so number 4, is covered under chapter, hold on. I think chapter 7. No, not chapter 7. Let me check and make sure. Yes, chapter 8. Actually, assignment 17. So let's look at number 4. All right, everybody got to number 4? Number 4 says a component of protein called serine has an approximate molar mass of 105 grams per mole. If the percent composition is as follows, what is the empirical and molecular formula of serine? All right. And I think this is going to be the last question that we're going to do today. So let me try to do this as quickly as possible. So they gave you the percent data for each of the elements, right? So carbon, the elements are carbon, hydrogen, oxygen, and nitrogen. Those are the 4 elements, right? And if you remember, we said that whenever you're doing these kinds of problems, you can assume that you're working with 100 grams of the particular substance, because by doing that, the percentages will be equal to the masses in grams of each of these. So I'm going to start off with the carbon, which is 34.95 grams. The hydrogen, which is 6.844 grams. Oxygen is 45.56 grams. And nitrogen will be 13.59 grams. And then what do we do next? Can anybody tell us? What's the next line here? Well, okay, we use the molar mass. So how do we use the molar mass? What are we trying to find by using the molar mass? We're trying to find what? The number of moles, exactly. So the next line would be the moles, right? So in the case of carbon, what do we multiply by? 34.95 grams multiplied by what? Well, you're going to divide by 12.01 grams. But up here, you're going to have 1 mole. All right? And we do the same thing for the other elements. So in the case of hydrogen, it is 6.844 grams multiplied by 1 mole over 1.008 grams. In the case of oxygen, is 45.56 grams multiplied by 1 mole over 16.00 grams. And then in the case of nitrogen, is 13.59 grams multiplied by 1 mole over the molar mass, which I think is 14.01. Let me just do a quick check just to make sure. Nitrogen is 14.01, yes. So 14.01 grams, all right? So we need to work out each of these. So please check with me to make sure I'm doing the right thing, because I could be making a mistake, all right? So in the case of carbon, it's 34.95 divided by 12.01. So according to my calculations, this works out to be 2.910 moles. And then in the case of hydrogen, it is 6.844 divided by 1.008. And that gives, according to my calculation, that gives 6.7, okay, round off to 4 sig figs. So that would be 6.790 moles. And then in the case of oxygen, is 45.56 divided by 16. So that gives, rounded off to 4 sig figs, that would be 2.848, 2.848 moles. And then lastly, in the case of nitrogen, it's 13.59 divided by 14.01. And according to my calculations, this works out to be 0.9700 moles. All right. Okay, so now that we have calculated the moles of each of these, what would be the next step? Well, what will be the next step? Divide all of them by the smallest mole number. You're absolutely correct. So the smallest one is this one right here. So when that is divided by itself, you're going to get 1 here. So you're going to divide by 0.9700 moles. So that would be 2.910 moles divided by 0.9700 moles for that one. For this one, 6.790 moles divided by 0.9700 moles. And then for this one, it's 2.848 moles divided by 0.9700 moles. Okay, so let's see what we get as a result of this. Let me move this up here. So 2.910 divided by 0.9700. Okay, so this gives me 3 exactly, but I'll round it off to 3.000 4 sig figs. Let me do that again just to be sure. Okay, and then for the next one, 6.790 divided by 0.970. Oh, that gives you exactly 7. So 7.000. And then 2.848 divided by 0.970. Okay, now this one gives me 2.936. All right. So from the look of things, this would be 3, this would be 7, and this would be approximated to 3 because it's 2.936. So you can round it up to 3, and that would be 1. So therefore, the empirical formula will be C3H7ON. So that's the empirical formula, right? Now the question, let me go back to the question here. The question is asking for not only the empirical formula, but also the molecular formula. Now, what I would have to do is find the empirical mass. Let's see, sorry. Whoops, sorry. Okay, I'm running out of space here. So the empirical mass, I'm going to cheat and use my calculator here. So the formula is C3H7. Oh, my bad. This should be 3 right here beside the oxygen because of this 3 right here. So C3H7O3N. Okay, so according to the molar mass calculator I'm using, the empirical mass is 105.09 grams per mole. And that is approximately equal to the molar mass, right? So therefore, the molecular formula will be the same thing as the empirical formula, which is C3H7 H7O3N. So the empirical formula and the molecular formula are both one and the same. All right? And that's basically how you'd answer that question. All right? Any questions about that one? Any questions about this example? Okay, can we do, let's see here. Can we do C? Let's see if we can do C in the time that we have left. But I want to make sure everybody understands what we did here, right? So any questions about this one? Any questions? All right, so let me get rid of this and move on to the C part. It says 50.51 gram sample of a compound made from phosphorus and chlorine is decomposed. The analysis of the product showed that 11.39 grams of phosphorus atoms were produced. What is the empirical formula of the compound? Well, in this case, we know what the mass of phosphorus is. Do this over here. The mass of phosphorus is 11.39 grams. So to find the mass of chlorine, that would be equal to the 50.51 grams minus the 11.39 grams. And according to my calculation, that is equal to 39.12 grams. So the next thing I would do is construct a table, phosphorus, chlorine. The first row will have the masses. So I'm going to have 11.39 grams and 39.12 grams. And then just like we did before, we determine the moles by dividing, in this case, 11.39 grams by, well, multiply by 1 mole over the molar mass of phosphorus, which is, phosphorus is 30.97 grams. And then in the case of chlorine, we multiply 39.12 grams by 1 mole over the molar mass of chlorine, which is 35.45 grams. And then we use our calculators to do the number crunching for each of these. So 11.39 divided by 30.97. And according to my calculation, this gives you 0.36, okay, 0.3678 moles. And then in the case of phosphorus, it is 39.12 divided by 35.45. And according to my calculation, this works out to be 1.104 moles. And then the next row is where we divide by the lower of these two, which in this case would be the 0.3678 moles. That will give you 1 here, and 1.104 moles divided by 0.3678 moles. Work that out. So 1.104 divided by 0.3678. And according to my calculation, this gives 3.001, actually 3.002, which approximates to 3. So therefore the formula, the empirical formula for this compound is PCl3. And that's how you do that. All right, any questions about that one? Any questions? Okay, So that's the last question. Well, actually, the last question was a stupid question I posted just to give my students some extra points. But, so that's basically it as far as this review is concerned. So I don't know if you guys have any questions in the remaining 6 minutes that we have here. But that's basically what I've just covered is pretty much what the test you'll be getting next week will be about. All right, so I would strongly recommend that you review all your assignments, review the assignment keys, which by the way, I've posted in Canvas, so you can go check that out and you can review what we just did. And in addition to that, I would suggest that you try to do as many questions as you can from your textbook. And if you have any questions, feel free to contact me. I have office hours tomorrow on Skype from 2 to 5, and then on Friday from 12 to 5. So if you have any questions you want to ask me during that time, you can ask those questions. Okay, let me see here. Somebody is asking something in the chat. When are the tests due? On Friday. Friday, not this Friday, of course, next week, Friday at midnight. And again, make sure, and I'm going to put this, of course, in Canvas, make sure that the test is done in ink. I've had some issues. I don't know if it was you guys or some other class, but I've had some issues with reading what you have written down, right? Make sure it's done in ink. Make sure it's your own handwriting, so no typewritten work. And make sure that it is saved and submitted as a PDF document. All right, so after you scan it, make sure you save it as a PDF, and then you can upload it into the Canvas system, the actual portal for the test. All right. Okay, any other questions? Okay, so if there are no other questions, that's pretty much it for today. So enjoy the rest of your evening, and I'll see you next Monday. All right. All right, so take care.